somewhere in France, August 1944. While Patton's tanks roared across Europe at speeds the world had never seen, thousands of unsung heroes worked through mud, blood, and darkness to keep those steel beasts alive. This is the story of how one man's wrench became as vital as any general's strategy. Without mechanics like him, Patton's legendary dash across Europe would have stalled before it began. Fort Benning, Georgia, December 1941. The United States had just entered World War II, and nowhere was the urgency more palpable than at Fort Benning, Georgia. Here, amid the red clay and pine forests of the American South, the U.S. Army was scrambling to build an armored force that could stand against Hitler's panzer divisions. Among the thousands of young men streaming through the gates was a mechanic from Indiana named Jack Sullivan, a composite representation of the countless maintenance men who would keep America's armor rolling. Sullivan had grown up working on tractors and automobiles in his father's repair shop in rural Indiana. His hands knew the language of engines, the subtle dialects of grinding gears and misfiring cylinders. When his draft notice arrived in early 1942, he didn't know that his grease-stained fingers would become instrumental in one of history's most audacious military campaigns. The Army recognized Sullivan's mechanical aptitude immediately. After basic training, he was assigned to the newly formed armored divisions and sent to advanced training at the Desert Training Center near Indio, California. This was General George S. Patton's domain, a vast expanse of Mojave Desert where American soldiers learned the brutal realities of mechanized warfare. Patton, already a legend in armored warfare circles, had designed this training center specifically to simulate the harsh conditions of North Africa. The desert was merciless. Temperatures soared above 100 degrees during the day and plummeted at night. Sand infiltrated every mechanism, every seal, every bearing. For mechanics like Sullivan, the desert became both classroom and crucible. We learned that tanks don't just break down from enemy fire, Sullivan would later recall in his letters home. Heat, dust, and distance, those were our real enemies. A tank could throw a track in the middle of nowhere, and if you couldn't fix it fast, men died. The training was relentless. Patton demanded that every tank company understand the importance of preventive maintenance to keep their steel horses running. Mechanics worked 16-hour days in conditions that would break lesser men. They learned to strip and rebuild Sherman tank engines in complete darkness. They practiced emergency repairs under simulated artillery fire. They discovered creative solutions using whatever materials were at hand. The Sherman M4 medium tank was the workhorse of the American armored force. It was reliable by the standards of the day, but that meant it still broke down with alarming frequency. The Continental R-975 radial engine, borrowed from aircraft design, was temperamental. The suspension, while revolutionary, required constant attention. The tracks, each link weighing nearly 40 pounds, wore out quickly on rough terrain. Sullivan and his fellow mechanics became intimately familiar with every bolt, every gasket, every specification of these 30-ton machines. They learned that a Sherman required meticulous care. Oil changes every 500 miles. Track tension checks daily. Coolant levels monitored constantly in the desert heat. A good mechanic could hear problems developing before they became critical, a slight knock in the engine that signaled bearing wear, a squeal in the tracks that meant impending failure. But technical knowledge alone wasn't enough. Patton's training regime emphasized something else: speed. In mechanized warfare, time meant everything. A tank broken down for days was a tank lost. Mechanics had to work fast, often under combat conditions, with limited tools and parts. They had to improvise, adapt, and overcome obstacles that would stump even factory-trained technicians. The general used to say that an army moves on its stomach, Sullivan wrote. But armored divisions move on their mechanics' backs. We carried spare parts, tools, and the burden of keeping those beasts alive. The training also revealed a harsh truth that would define mechanized warfare in Europe: logistics determine victory. Even the best tank was useless without fuel, ammunition, and spare parts. Even the most skilled crew was helpless if their vehicle couldn't move. The supply chain, from factory to battlefield, had to function flawlessly. By mid-1943, Sullivan's unit, the 4th Armored Division, was among the most combat-ready formations in the Army. They had been training together since 1941, an eternity in wartime. They knew their vehicles. They knew each other. They were as prepared as peacetime training could make them. Yet nothing could fully prepare them for what was coming. In September 1943, Sullivan and his division boarded troop transports bound for England. As the grey Atlantic waters churned below, thousands of young men contemplated the reality that awaited them. Many wouldn't return. In England, based out of Warminster Barracks, the 4th Armoured Division conducted final preparations for Operation Overlord. The mechanics finalized the division's equipment specifications. Each tank battalion wielded 2 companies of M4 Sherman medium tanks and 1 company of M5 Stuart light tanks, 15 tanks per company, 54 tanks total per battalion. Supporting them were medical sections, supply personnel, staff, and mechanics like Sullivan, all contributing to an authorized strength of 504 soldiers per battalion. The Salisbury Plains provided the final training ground. Here, in the frigid English winter, mechanics learned lessons that would save countless lives in Europe. They discovered that cold weather brought its own challenges, engines that refused to start, oil that thickened to sludge, tracks that froze solid overnight. Sullivan's unit also received critical intelligence about what they'd face in France. The German army, though retreating, remained formidable. Their tanks, the Panther and Tiger models, were technologically superior to the Sherman in armor and firepower. The German long-barreled 75mm cannon could pierce a Sherman's frontal armor at ranges where American guns were ineffective. This knowledge placed even greater pressure on the mechanics. American armor would win through speed, reliability, and numbers, not through technological superiority. That meant keeping as many tanks operational as possible, at all times, no matter the conditions. We knew our Shermans were outgunned, Sullivan later reflected. But we also knew they were more reliable than the German tanks. Our job was to make sure that advantage counted for something. As D-Day approached, nervous energy pervaded the camps. Everyone understood that the invasion of Europe would be the largest amphibious operation in history. Success was far from guaranteed. The mechanics checked and rechecked every vehicle, knowing that mechanical failure during the landing could doom not just a crew but an entire operation. Sullivan and his fellow mechanics prepared for the unthinkable. They waterproofed engines for the beach landing. They prepositioned spare parts and tools. They mentally rehearsed emergency procedures for every conceivable breakdown. Their preparation was meticulous because they understood a fundamental truth of mechanized warfare: battles are won by the side whose vehicles keep running. By the time June 1944 arrived, Jack Sullivan had transformed from a small-town mechanic into a combat engineer ready for the greatest challenge of his generation. Normandy, France, August 1944. D-Day came and went without Sullivan's unit. While the first waves crashed onto the beaches of Normandy on June 6, 1944, the 4th Armored Division waited in England. General Patton himself was sidelined, commanding a phantom army, the 1st U.S. Army Group, designed to deceive the Germans about where the real invasion would occur. For nearly 2 months, Sullivan and his comrades listened to reports from France with a mixture of relief and frustration. The landings had succeeded, but progress inland was agonizingly slow. American and British forces were locked in brutal hedgerow fighting, gaining yards at a time against determined German resistance. Everything changed in late July. Operation Cobra, the breakout from Normandy, smashed through German defenses and created the opening Patton had been waiting for. On August 1, 1944, the Third Army officially entered combat, and the 4th Armored Division spearheaded its advance. Sullivan crossed the English Channel aboard a landing ship tank, the deck crowded with Shermans secured against the rolling sea. Landing at Utah Beach, the evidence of the invasion's fury was everywhere: shattered concrete bunkers, twisted metal obstacles, and the detritus of battle scattered across the sand. The beach was still a mess when we landed, Sullivan remembered. But there was no time to think about it. We had to move inland immediately. The general was already raising hell about getting his tanks forward. Patton's strategy was revolutionary. Rather than fighting for every village and crossroad, Third Army would bypass enemy strongpoints and race eastward, exploiting the breakthrough with unprecedented speed. This armored column doctrine relied on maintaining momentum, and momentum depended entirely on mechanical reliability. The advance began almost immediately. Sullivan's battalion joined Combat Command A of the 4th Armored Division, driving east toward Avranches. The pace was blistering. Columns of tanks moved 24 hours a day, covering distances that seemed impossible to military planners raised on World War I experience. For the mechanics, the reality was stark. They had to keep dozens of tanks operational while moving at speeds up to 50 miles per day over roads never designed for such traffic. Broken-down tanks couldn't be left behind, they were too valuable. Recovery and repair had to happen on the move. Sullivan quickly developed a routine that would sustain him through the coming months. Each time the column halted, even for minutes, mechanics swarmed over their vehicles. They checked track tension, topped off oil and coolant, listened for unusual sounds. They carried basic spare parts in their tanks, track links, engine filters, fan belts, anything that might fail and could be quickly replaced. The French roads proved treacherous. Narrow lanes lined with stone walls limited movement. The infamous hedgerows of Normandy gave way to rolling farmland, but the roads remained medieval in character. Tanks threw tracks regularly on sharp turns. Suspensions failed under the constant pounding. Transmissions overheated from the relentless pace. Sullivan witnessed firsthand the ingenuity that kept American armor moving. When official spare parts ran short, mechanics improvised. They salvaged parts from destroyed German vehicles. They modified civilian equipment to serve military purposes. They created field expedient repairs that would horrify factory engineers but kept tanks operational. We modified 14,000 German spark plugs to work in Sherman engines, Sullivan noted in his diary. The ordnance guys said it couldn't be done. We did it anyway because we had to. The first major test came at Argentan in mid-August. The 4th Armored Division was racing to close the Falaise pocket, attempting to trap two entire German armies. Sullivan's battalion reached its positions ahead of schedule, but several tanks had developed serious mechanical problems during the dash. Working through the night in blackout conditions, any light could draw enemy artillery. Sullivan and his crew performed what should have been a depot-level engine replacement in the field. Using a tank recovery vehicle and sheer determination, they pulled the engine from a Sherman, swapped in a rebuilt unit they'd been carrying, and had the tank operational by dawn. You do things in combat you'd never attempt in peacetime, Sullivan explained. We had a tank that needed a new engine. We had a spare engine. The alternative was leaving that tank behind, and that wasn't acceptable. So we figured it out. The Falaise pocket ultimately closed, though not as completely as Patton wanted. Between 20 and 40,000 German soldiers escaped the trap. Still, the victory was significant, and Third Army continued its relentless push eastward. By late August, Sullivan's division had traversed 60 miles in 2 weeks, an average of 4 miles per day of continuous combat operations. The achievement was unprecedented in military history. But the cost to the vehicles was enormous. Nearly every tank required some level of maintenance. Track wear was catastrophic. Engines were running far beyond their normal service intervals. The greatest challenge emerged as Third Army approached the German border: fuel. The spectacular advance had outrun Allied logistics. Every gallon of gasoline had to be trucked forward from the Normandy beaches, a distance that grew by dozens of miles each day. The famous Red Ball Express, a dedicated truck convoy system, struggled to keep pace. When fuel supplies dwindled to crisis levels in early September, Sullivan experienced the frustration shared throughout Third Army. His tanks were mechanically sound, ready to continue the advance. But without fuel, they sat idle. For mechanics who had worked themselves to exhaustion keeping vehicles operational, the forced halt was maddening. We could have been in Germany by September, Sullivan believed. Our tanks were ready. The men were ready. But we couldn't move without gas. The general was furious, but there was nothing anyone could do. The halt at the German border, imposed by logistics rather than enemy action, marked the end of Third Army's spectacular summer dash across France. In 60 days, they had covered nearly 600 miles, liberated thousands of towns, and destroyed or captured German forces 6 times their own strength. It was arguably the most successful armored campaign in history. But for Sullivan and his fellow mechanics, the pause brought a different kind of challenge. Every tank needed major maintenance. Engines had to be rebuilt. Transmissions required overhaul. Tracks needed replacement. The wear and tear of 2 months of continuous operations had pushed every mechanical system to its limits. Maintenance facilities were established in captured French factories. Sullivan found himself working in a converted automotive plant in Nancy, supervising engine rebuilds with the help of French civilian workers. The respite allowed systematic maintenance that had been impossible during the advance. We had tanks that had run for 60 straight days, Sullivan recalled. Some had over 1,000 miles on them since the last proper service. We basically had to rebuild the entire division's worth of vehicles. The mechanics also prepared for winter. Experience had taught them that European winters were harsh, and their vehicles would need modifications to operate in snow and freezing temperatures. They requisitioned cold weather equipment, installed engine heaters, and stockpiled antifreeze. As September turned to October, Third Army prepared for the next phase of operations. The pause had been frustrating but necessary. The logistics system was catching up, supply dumps were being established closer to the front, and most importantly, the tanks were ready. Sullivan had survived his baptism by fire. He had learned lessons that no peacetime training could teach. He had discovered capabilities within himself he never knew existed. And he knew the hardest fighting still lay ahead. Luxembourg, December 1944. Winter descended on Europe with brutal severity. By December 1944, Third Army was locked in fierce fighting around the fortress city of Metz, grinding through German defenses that had been strengthened over decades. The weather turned cold and wet, transforming French roads into rivers of mud that added new torments to tank operations. Sullivan and his mechanics adapted to winter warfare. The challenges were different but equally demanding. Engines that had overheated in summer now refused to start in sub-zero temperatures. Oil thickened to the consistency of cold syrup. Batteries died overnight. Tracks froze to the ground. We learned to keep engines running whenever possible, Sullivan wrote. Starting a cold engine could take hours and drain batteries we couldn't easily replace. So we ran them continuously, which meant constant fuel consumption and increased wear. The maintenance routine expanded to include cold weather procedures. Mechanics drained radiators nightly and refilled them each morning to prevent freezing. They wrapped batteries in insulation. They developed techniques for breaking tanks free when tracks froze to the ground overnight. The fighting around Metz was savage and slow. German defenders used the fortress's massive fortifications to exact a heavy toll on American armor. Sullivan's battalion lost several tanks to anti-tank guns positioned in hardened bunkers. While he couldn't repair combat damage, that required depot facilities, he could keep the surviving tanks operational through the constant grind of positional warfare. Then came December 16, 1944. German forces launched a massive surprise counteroffensive through the Ardennes forest, a region considered too difficult for large-scale armor operations. The attack caught American forces completely off guard, creating a bulge in the Allied lines that threatened to split the entire front. Most devastatingly, the attack isolated the 101st Airborne Division and other units in the Belgian town of Bastogne. Sullivan first heard about the crisis through the military grapevine. Rumors spread through the maintenance depot before official orders arrived. Something big was happening to the north. Third Army might be called upon to respond. What came next would become legendary in military history. General Eisenhower, the supreme Allied commander, ordered Patton to disengage from the Metz offensive, turn his entire army 90 degrees north, and relieve Bastogne. It seemed impossible. Moving an entire army, hundreds of thousands of men, thousands of vehicles, in winter conditions over questionable roads on short notice defied conventional military planning. But Patton's intelligence officer, Colonel Oscar Koch, had anticipated the possibility of a German counteroffensive. Contingency plans had been prepared. And crucially, the mechanics had kept the vehicles ready. "We got the order on December 19, Sullivan remembered. Turn north, move immediately, maximum speed. Everything we'd worked for over the past months came down to this." The movement of Third Army toward Bastogne remains one of the most impressive logistical achievements in military history. Sullivan's 4th Armored Division would spearhead the relief effort. Every tank had to be operational. There was no time for repairs en route. Vehicles that couldn't move immediately would be left behind. Sullivan and his fellow mechanics worked through the night of December 19 to 20. Every vehicle was checked and rechecked. Fuel tanks were topped off. Spare parts were distributed. Emergency repair kits were prepared. The temperature was below freezing, snow was falling, and the work had to be done in darkness to avoid German aerial reconnaissance. "I remember thinking this was it," Sullivan said. "Everything we'd trained for, everything we'd learned, came down to this moment. If our tanks didn't start, if they broke down on the road, American soldiers would die at Bastogne." The column moved out before dawn on December 20. The roads were treacherous, covered with ice and snow. Visibility was poor. The pace demanded by Patton seemed suicidal in such conditions. Yet the tanks moved. Sullivan rode in a maintenance vehicle near the middle of the column, ready to respond to any breakdown. The cold was brutal. Ice formed on every exposed surface. The vehicle's heaters barely functioned. But the column pressed on. The first major breakdown occurred 10 miles into the march. A Sherman threw a track on an icy patch of road. The column couldn't stop, vehicles behind would pile up. Sullivan's crew had to perform the repair while other tanks flowed past them, then raced to catch up. Replacing a thrown track in normal conditions was hard work. In sub-zero temperatures, with frozen metal and numb hands, it was agony. The crew used blowtorches to warm the track links enough to make them workable. They hammered frozen pins with sledges that seemed to weigh 100 pounds. After 90 minutes of brutal labor, the tank was mobile again. That scene repeated itself dozens of times over the next 3 days. Tanks broke down. Mechanics fixed them. The column continued. Sleep became a luxury measured in minutes. Food was eaten cold from cans because stopping to heat it wasted time. The temperature never rose above freezing. Sullivan's battalion reached the outskirts of Bastogne on December 22, but it would take 4 more days of savage fighting before a corridor to the surrounded troops was secured. On December 26, elements of the 4th Armored Division broke through German lines and made contact with the defenders. "When we finally reached Bastogne, the guys who'd been surrounded looked like ghosts," Sullivan remembered. They'd been out of supplies, running low on ammunition, taking casualties they couldn't evacuate. But they'd held. And we'd gotten there. Somehow, against all odds, we'd gotten there. The relief of Bastogne marked the turning point in the Battle of the Bulge. The German offensive, already running low on fuel and supplies, had lost its race against time. American forces began pushing back, compressing the bulge from both sides. For Sullivan and his mechanics, the battle continued. The fighting in the Ardennes lasted through January 1945, conducted in the worst winter weather Europe had seen in decades. Mechanics worked in conditions that defied description, temperatures well below zero, constant snow, limited shelter. The mechanical toll was catastrophic. Engines seized from cold. Transmissions failed from the constant strain of moving in snow. Tracks broke with alarming frequency on frozen ground. Every day brought new challenges that required innovation and determination to overcome. Sullivan's crew developed new techniques for winter repairs. They learned to use fires to warm frozen components without damaging them. They discovered that certain parts from destroyed German vehicles could be adapted for use in American tanks. They created improvised shelters that provided some protection from the elements while they worked. You can't understand cold until you've tried to turn a wrench with hands so numb you can't feel them, Sullivan wrote. But you do it because men are depending on you. Because without your tank, they're exposed. Because giving up isn't an option. By the end of January 1945, the Battle of the Bulge was over. German forces had been pushed back to their starting positions. The Allies had lost ground but maintained their foothold in Europe. Most importantly, Germany had expended resources and manpower it could never replace. Third Army's role in the victory had been decisive. The rapid movement to Bastogne, achieved in impossible conditions, had demonstrated the effectiveness of American armored doctrine. And that doctrine depended entirely on mechanics like Jack Sullivan, who kept the tanks moving when conventional wisdom said it couldn't be done. March 1945. With the Bulge reduced and German forces in full retreat, Third Army resumed its eastward drive. The objective now was clear: cross the Rhine River and drive into the heart of Germany. The end of the war was in sight, but the fighting remained fierce. Sullivan's battalion had been in continuous combat for 7 months. The men were exhausted. The vehicles were worn beyond normal tolerance. Yet they continued to function through a combination of skilled maintenance and sheer will. The approach to the Rhine required crossing multiple rivers, the Moselle, the Saar, and their tributaries. Each river represented both an obstacle and an opportunity. The Germans used rivers as defensive lines, but American forces had perfected the art of river crossings through hard experience. For mechanics, river crossings presented unique challenges. Tanks had to be waterproofed. Engines had to be protected from water ingress. Exhaust systems needed special modifications. The work was painstaking and had to be done under combat conditions, often with enemy forces still engaged on the far bank. Sullivan's expertise in waterproofing had been developed during preparations for D-Day. Now he applied those lessons to multiple crossings as Third Army advanced. The work was technical and demanding, but failure meant a drowned tank and likely a drowned crew. We used everything we could find to seal those tanks, Sullivan recalled. Rubber gaskets, tar paper, even chewing gum in some cases. People think tanks are sealed machines, but they're full of openings for air intake, exhaust, and other systems. You had to seal everything or water would kill the engine. March 1, 1945 brought one of the war's famous moments. Third Army captured Trier with just 2 divisions. When headquarters sent a message suggesting Patton needed 4 divisions to take the city and asking if he wanted to bypass it, Patton's response became legendary: "Have taken Trier with 2 divisions. Do you want me to give it back?" Sullivan was there for the capture. His battalion entered the city behind the initial assault forces, ready to recover damaged vehicles and maintain the operational tanks. The speed of the capture left German forces no time to organize effective resistance. The capture of Trier opened the route to the Rhine. Over the next 10 days, Third Army cleared the entire region north of the Moselle River, trapping thousands of German soldiers. They then joined the 7th Army in sweeping the Saar and the Palatinate, capturing 100,000 prisoners. The culmination came on March 22, 1945. Third Army crossed the Rhine near Oppenheim, and unlike the famous crossing at Remagen, the Oppenheim crossing was opposed. German forces fought desperately to prevent American armor from establishing a bridgehead on German soil. Sullivan was with the second wave across. His maintenance team set up operations on the eastern bank within hours of the initial assault. Tanks that broke down during the crossing had to be repaired immediately. There was no room on the far side for disabled vehicles, and they couldn't be left on the western bank when the fighting had moved east. The Rhine crossing felt like the beginning of the end, Sullivan remembered. We were in Germany now. The enemy was on their home ground, fighting desperately, but we could feel they were finished. Our job was to keep the pressure on, keep moving, don't let them reorganize. Third Army's dash across Germany in March and April 1945 rivaled the pace of the previous summer's advance across France. The difference was that this advance was contested every mile. German forces fought from every village, every hill, every forest. But they could no longer stop the American juggernaut. Sullivan's maintenance routine now included salvaging parts from destroyed German equipment. The Third Army captured so much material that supply officers organized entire warehouses of captured equipment. Mechanics learned to identify which parts could be modified for use in American vehicles. We had warehouses full of German motorcycles that we rebuilt with captured spare parts and reissued to our troops, Sullivan noted. The Germans had excellent mechanics and good equipment. When we captured it, we put it to use. The pace of advance in Germany averaged 20 to 30 miles per day. Sullivan's battalion covered vast distances, sometimes moving 100 miles in 48 hours. The mechanical strain was enormous. Tracks wore out completely and had to be replaced in the field. Engines ran thousands of miles past normal service intervals. Transmissions operated at temperatures that should have caused failure. But the tanks kept moving. Sullivan and his fellow mechanics worked miracles daily. They performed repairs that should have required factory facilities using whatever tools and parts were available. They improvised solutions to problems that had never been encountered before. They kept an entire armored division operational through some of the most demanding conditions in military history. By mid-April, Third Army was approaching Czechoslovakia and Austria. The German army was disintegrating. Resistance became sporadic and disorganized. The end was clearly near. On April 29, elements of Third Army liberated the Order of Concentration Camp, the first Nazi death camp encountered by American forces. Sullivan was among those who saw the horrors: emaciated prisoners, mass graves, evidence of systematic murder on an industrial scale. Nothing prepared us for that, Sullivan said, his voice still shaken decades later. We'd been fighting for months, seen death and destruction everywhere. But this was different. This was deliberate, organized evil. It changed how we understood what we'd been fighting against. More camps followed: Buchenwald, Mauthausen-Gusen. At each one, American soldiers confronted evidence of Nazi atrocities. The discoveries hardened any remaining sympathy for the enemy and reinforced the righteousness of the Allied cause. Third Army's advance ended in Czechoslovakia on May 8, 1945, Victory in Europe Day. After 10 months of continuous combat, covering more than 600 miles, the 4th Armored Division finally halted. The war in Europe was over. Sullivan stood beside his Sherman tank that day, a vehicle that had carried him across most of Europe. It was battered, worn, held together by field expedient repairs and desperate measures. But it still ran. Like Sullivan himself, it had endured beyond what seemed possible. I thought about all the guys who didn't make it, Sullivan reflected. The tank crews who died when their vehicles were hit. The mechanics who were killed by artillery while working on repairs. The friends I'd made and lost. We'd won, but the cost was terrible. In its 10-month campaign, Third Army had been in continuous combat for 281 days. It had crossed 24 major rivers and captured 81,500 square miles of territory, including more than 12,000 cities and towns. The Third Army claimed to have killed, wounded, or captured 1.8 million German soldiers, 6 times its own strength and personnel. Those achievements would have been impossible without mechanics like Jack Sullivan. While generals planned strategy and tank crews fought battles, mechanics kept the machinery of war functioning. They were the invisible force that made armored warfare possible. Germany, June 1945. With the war in Europe concluded, Third Army transitioned to occupation duties. Sullivan's unit was stationed in Bavaria, where they faced the complex task of maintaining order in a defeated nation. The occupation brought new challenges but offered the first respite from combat operations in nearly a year. For the first time since August 1944, mechanics could perform proper maintenance without urgency. They could rebuild engines correctly, replace worn parts, restore vehicles to proper operational standards. Sullivan supervised the complete overhaul of his battalion's vehicles. It was satisfying work after months of emergency repairs and field expedient solutions. Tanks that had been held together by ingenuity and determination received the attention they deserved. But the work also provided time for reflection. Sullivan had been 22 years old when he arrived in Normandy. He was now 23, but he felt decades older. He had witnessed things no one should see, done things he never imagined possible, and discovered capabilities he didn't know he possessed. "I learned that people can do extraordinary things when they have to," Sullivan said years later. "We kept those tanks running because failure wasn't an option. Men depended on us. The mission depended on us. So we found ways to make the impossible work." The mechanics of Third Army represented thousands of men whose contributions rarely made headlines. While Patton became a household name and tank commanders earned recognition for their victories, the mechanics remained largely anonymous. Yet their role was equally crucial. Modern military historians have come to appreciate what contemporary observers often missed: mechanized warfare was as much about logistics and maintenance as about tactics and strategy. The side whose vehicles kept running had an enormous advantage. American armor succeeded in Europe largely because it was more reliable and better maintained than German armor. Sullivan remained in Germany until early 1946, when he was finally shipped home. He returned to Indiana, to the small-town life he had left behind 4 years earlier. The adjustment was difficult. How do you explain to people who haven't experienced war what it was actually like? How do you convey the intensity, the exhaustion, the constant pressure of knowing that lives depended on your work? He returned to his father's repair shop, but civilian mechanics seemed trivial after maintaining tanks in combat. Eventually, he established his own business and built a successful life. He married, raised a family, and became a respected member of his community. But he never forgot Europe. He never forgot the friends who didn't come home. He never forgot the desperate repairs in freezing weather, the exhaustion so profound he could barely stand, the satisfaction of getting a broken tank running again when everyone else said it was impossible. In the decades after the war, Sullivan occasionally spoke to school groups and veterans organizations about his experiences. He was always careful to credit the teams he worked with rather than claiming individual glory. "I was just one mechanic among thousands," he would say. "We all did our jobs. The guys in the tanks got the glory, and they deserved it, they were the ones facing the enemy directly. But we were proud of what we did. We kept the tanks moving. We made it possible for them to fight." The story of mechanics like Jack Sullivan illustrates a fundamental truth about military operations: success depends on countless individuals performing unglamorous but essential tasks. For every general planning strategy and every soldier fighting battles, there are dozens of support personnel making operations possible. Third Army's spectacular campaign across Europe was built on a foundation of logistics and maintenance. The mechanics who kept vehicles operational, the truck drivers who delivered supplies, the communications technicians who maintained radios, the medics who treated the wounded, all contributed to victory. Sullivan lived to see the 50th anniversary of D-Day in 1994. He returned to France for the commemorations, walking the beaches where he had landed 50 years earlier. The experience was emotional and bittersweet. "I saw the cemeteries full of white crosses," he recalled. "So many young men who never came home. I thought about how lucky I was to survive, to have lived a full life that they never got to experience. And I thought about how all of us, the ones who came home and the ones who didn't, we were part of something larger than ourselves." Jack Sullivan passed away in 2001 at the age of 78. His obituary in the local newspaper was brief, mentioning his service in World War II and his successful business career. It didn't detail his crucial role in one of history's most successful military campaigns. It didn't describe the desperate repairs performed in impossible conditions. It didn't capture the skill, determination, and courage required to keep tanks operational through 10 months of continuous combat. But to those who understood mechanized warfare, to those who appreciated the complexities of military logistics, Sullivan's contributions were immeasurable. He represented a generation of mechanics who made modern warfare possible. Without them, even the best generals and bravest soldiers would have been impotent. The tanks Sullivan maintained are now museum pieces. The M4 Sherman, once the workhorse of American armor, is a relic from another era. Modern tanks are vastly more complex, equipped with computerized systems that Sullivan could never have imagined. Yet the fundamental truth remains unchanged: military machines require dedicated maintenance personnel. The high-tech vehicles of 21st-century warfare depend on mechanics just as much as the Shermans of World War II did. The tools have changed, the technology has advanced, but the essential role remains the same. Sullivan's legacy lives on in every military maintenance unit, every dedicated mechanic who works long hours to keep vehicles operational, every technician who understands that their work, while unglamorous, is absolutely essential to mission success. This is how one army mechanic kept Patton's tanks moving across Europe. Through skill, determination, and courage, Jack Sullivan and thousands like him made history, one repair at a time.